I want to see comments. No? Mic is on. They are not shared also. Good evening. Good evening, Akhil Tripathi. Good evening, beta. Let's wait for others to join, right? Then we'll start the revision of this chapter. Because in the last class, a few students has demanded they wanted to revise this chapter, right? So let's revise this. Whosoever has joined, they have to give their introduction by writing your name. You can write your name, beta. Am I audible? Yes, Akhil? Good evening, Devansh. Good evening. Who else has joined? Only 2 students are there. Whosoever has joined, they have to write. You have to write your name, beta. Devansh, yes, ma'am, you are audible. Thank you, Devansh. Thank you. Okay. Thank you, Akhil. Okay, good. So can we start? So let's start with this. Now we know that we are going to start revision of this chapter, is matter around us pure? And if you remember in the first chapter, good evening Priyansh, good evening. In the first chapter we have studied about the states of matter, and in this chapter we are going to study whether this matter is pure or impure and how many kind of matter is present in the atmosphere, right? So on the basis of chemical composition we can classify matter into 2 main types, pure substances and mixture. But how we can find out whether they are pure or impure? There should be some criteria for deciding. So on the basis of chemical composition, the matter can be divided into 2 main types, pure substances and mixture. And the pure substance once again are 2 types, these are elements and compounds, and mixtures are 2 types. Once again, mixture are also 2 types, homogeneous and heterogeneous mixture. Homogeneous and heterogeneous mixture. So in the next slide we are going to yes. So in what are pure substances? Pure substances always contain a single type of substance, or you can say it may be containing single type of substance. It can be element or it can be compound. We know that pure substances could be 2 types. One is element or compounds, and if it contains one kind of atoms only, it means they are having what? They are having elements. If they contain one kind of molecule, it means we are talking about compounds, right? And the mixtures, what are mixture? Mixture is a substance which may contain two or more different kind of pure substances. Divyansh, okay, initially Divansh was there, now Divyansh is there. Good evening, Divansh. Okay, so now you can see mixture is a substance which consists of two or more pure substances. For example, seawater is a mixture, all minerals are mixture, soil is mixture, okay, and air, soil, air, sand, salt, sugar is mixture, right? Sugar in water is mixture, salt in water is mixture, right? Now if I ask you to differentiate between pure substances and mixture, so it can be easily, it's buffering. Is it working or not working? You have to give me response. Is it working? Hmm? So we'll continue with that. So how we can differentiate between pure substances, right, and mixtures? We know the pure substances consist of a single type of substance, and mixture consists of two or more pure substances. If you mix two substances together, is anyone able to hear, ma'am? Hmm. Hmm. Can you hear me now? No? Can you hear me now? Yes, it's working now. Yes, it's working now. Okay, good. It's working now. Okay, so let's continue. So we were discussing difference between the pure substances and impure substances, right? How we can differentiate pure substance with the impure substance? So we can easily see the difference if you find only one kind of atoms. If you now, it's not buffering, beta. No ma'am, still video is paused from your side. Yes ma'am, now you're audible. I think now this is working. Okay, so pure substance consists of a single type of substance, means it may be containing one kind of atoms or molecules, and mixture consists of two or more pure substances, right? Whenever we see the pure substances, they cannot be separated into any other substance by physical method. For example, you can't convert right? Pure substance cannot be separated into the other substances either by the physical mean or right. But when you see any compound can be separated into the other substances by chemical means, not by physical means, right? The mixture can be separated into its component by physical methods. If you take mixture, the mixture can be separated into the constituent particle by the physical method. For example, if it is a mixture of iron and sulfur, okay, good. If it is audible, wonderful. Okay, so pure substance has its own definite properties. For example, if you talk about any element, that is, they have their definite properties. That's why all metals, they show different kind of properties. But whenever we show the mixture shows the property of the constituent particle. For example, if it is a mixture of iron and sulfur, right? So if it is a mixture of iron and sulfur, so I'll show you, just wait. If we take this iron plus sulfur mixture in a china dish, right? If you have taken the china dish and there is a mixture of iron, and if you are using magnet, right? If we are using magnet to separate this, obviously the iron particle will cling to the magnet, right? So with the help of magnetic separation, with the help of this magnetic separation, we can easily separate the mixture of iron and sulfur. And if you have iron carbon disulfide solution, if you have CS2 with you, and with the help of CS2, the sulfur will dissolve in this, right? The sulfur can dissolve in this and we will get CS2 solution, right? CS2 solution. It will work better. It will work. Don't worry. I'm connecting with the internet. So now it's connected. Now it's a 2-minute lag. You must be watching the old video, right? It will be connected. Okay. So we were discussing today there is a lot of problem in the internet. Everyone is facing this problem because there is a lot of load in the internet, right? Once again it's buffering. No beta, it will be connected. Okay, so you can see that we can easily separate iron and sulfur. If it is a mixture of iron and sulfur, right? And in a china dish, we have taken iron and sulfur. So with this, Yes, now working. Yes, ma'am, you are audible. Okay, thank you very much, beta. You people are so responsible kids. I am very happy. You are giving very good feedback. Okay, so if it is a mixture of iron sulfur with the help of carbon disulfide solution, okay, or with the help of magnet, so either with the help of carbon disulfide solution or magnet, we can easily separate we can easily separate the mixture of iron and sulfur. It means iron and sulfur both are showing their individual properties. So if they are showing the individual properties, it means they are in a mixture. But when iron and sulfur will get heated, suppose if I take iron and sulfur and if I heat them, okay, if I heat them, I will get black mass of FeS. Now this is compound now. Okay, this has converted into compound, and compound is what? Pure substance. Okay, the pure substance, they have entirely different properties in comparison to when you see the compound properties. Compound constituent the compound properties are entirely different from its constituent particles, right? But if you see the mixture, this is mixture and this is compound. This is mixture and this is compound. Okay, so understood. So FeS means when it, and this is a black mass, hard mass, right? Okay, understood. So now we can see here in this, we can separate the constituent particle of mixture with the help of physical processes, but with the help of chemical processes. Now you can see here, if it is a mixture of iron and sulfur, iron can attract toward the magnet and sulfur can dissolve in carbon disulfide solution. If you have any of one option, suppose if you are having magnet, so you can easily separate a mixture of iron and sulfur with the help of magnetic separation, right? And if you have carbon disulfide solution in this, you will see that sulfur can dissolve in carbon disulfide solution, but iron cannot dissolve in this, right? So what is going to happen? What is going to happen? We can see, if you are not having magnet, if you have only carbon disulfide solution, then obviously the iron can be separated easily, because iron cannot dissolve in the carbon disulfide solution, but sulfur can dissolve. It means if iron is insoluble in carbon disulfide solution, so with the help of filtration we can separate iron from a mixture of iron and sulfur, right? It means they are retaining their properties, right? It means the constituent particle of the mixture, they retain their properties, but the constituent particle of the compound, now if you try FeS, now we have taken iron and sulfur and both gets heated. After heating, we'll get a black mass of iron sulfide. We'll get a black mass of iron sulfide. Now you can see the iron sulfide cannot be broke down into constituent particle either by the help of carbon disulfide solution or magnet. They cannot be separated. Why they cannot be separated? Now we, instead of it is a compound, and compound is a pure substance, right? The constituent particle of the pure substance cannot be broke down into its constituent particle by physical means. If you try to separate iron and sulfur in a compound, they cannot separate it. Okay, so these two cannot be separated. Is it clear with that? Okay, so let's go to the slide back. Now I hope this is clear. We'll go back to the slide. Now you can see we have already discussed now how many types of mixtures are there. We have already understood in the previous classes that if you take a mixture means what? If you take two or more type of pure substances, they can be easily separated with the physical physical processes. And if you mix two or three pure substances together, you are going to get you are going to get mixtures. But when you mix them, sometime you will not be able to see their separation boundary. There may be chances that there are 2 or 3 pure substances are mixed together, and then obviously they are going to turn to mixture, but you are not able to see their separation boundaries. If you are not able to see their separation boundaries, it means what is going to happen? What is going to happen? If you are not able to see the separation boundary, it means they are going to form homogeneous mixture. So on the basis of whether they can be easily separated into, you can see the separation boundaries or not. So if you are able to see separation boundary, it means those mixtures are heterogeneous in nature. If you are not able to see, it means they are homogeneous mixture. So mixture could be 2 types: homogeneous mixture, heterogeneous mixture. And homogeneous mixture is a mixture which has a uniform composition. Suppose if you dissolve salt in water, that will be homogeneous mixture, because when you take a sip of the salty water, the taste will remain same. The taste will remain same. Okay, likewise in heterogeneous mixture, when you see heterogeneous mixture, the mixture which has a non-uniform composition. So if you have a do it. Okay, so the particles of the mixtures are not visible by the naked eyes. So whenever you see the particle of homogeneous mixture, they are not visible at all by the naked eyes. Yes, I can see the masses are delivered late. Because beta, there is a 2-minute lag. Okay, Vaibhav, I have started this chapter once again because of you, because you wanted to revise this chapter. So I want, if you have any doubt, you can ask me, no problem. I will wait for your response, because I know there is a 2-minute lag in that. Okay. So whenever we see homogeneous mixture, it is a mixture which has a uniform composition, and the particle of these mixtures cannot be seen by the naked eyes, because the particles are very, very small in size. It means that's why generally homogeneous mixture means the true solution, right, where the particle size is less than 1 nanometer. Now, particle cannot be separated by the filtration. Why these cannot be separated by the filtration? Because the particle size is less than 1 nanometer. The nanometer means 10 to the power minus 9. Okay, so 10 to the power minus 9, because atomic radius is always measured in the nanometer. So the particle size, even the less than 1 nanometer, it means these cannot be seen by the naked eyes, or these cannot be even seen by the powerful microscope. So obviously they are the smaller, the particle of the matter homogeneous mixture are smaller than the pores of the filter paper. So if you try to separate them with the help of the filter paper, you will not be able to do that. Why? Because they will pass through the pores of the filter paper. So if they are able to pass through the pores of the filter paper, it means they are smaller than the pores of the filter paper, and then no separation can be done with the help of filtration. If you want to separate the constituent particle of the homogeneous mixture with the help of filtration, it's not possible. Why it's not possible? I have told you, the particle of this homogeneous mixtures are very, very small. Now, Akhil Tripathi wants to know that how compound is a pure substance. So, I know that I am getting this late messages, but I will explain you. Just wait, let me go to that. Now, how compound can be pure substances? Because whenever we say the pure substance, whenever I say water, right? So, Akhil, your question is how compound is a pure substance. Why compound is a pure substance? Because whenever we see, suppose if I give you the distilled water in a glass, that will contain only H2O molecule. I said, what is the criteria for deciding whether it's pure or impure? if you have only one kind of atoms or molecules, then we say it is a pure substance. And whenever you see compounds will always have a fixed composition. Okay, it will always have a fixed composition. And if you see compound, suppose if I talk about water is let's write that, you will better understand, right? So let's go back to the screen where we can work on that. Now I'll show you which pen we should. Green pen, I think more visible. So when I say water, right, water is what actually? And when we see water means that they are in a 2:1 ratio. They are in 2:1 ratio, right? And the hydrogen and oxygen, when we take their ratio by mass, we know that hydrogen mass number is 1 and oxygen mass number is 16. Since there are 2 atoms of hydrogen, so when we take the ratio by mass, it will be 2:16. And when we simplify this, okay, so when we simplify this, we'll get what ratio will be there? Yes ma'am, clear, please explain. Yes, I am explaining, beta. Okay, so 1:8 ratio. So whenever any compound will be formed, these the constituent elements are fixed, right? If you see the Dalton atomic theory will also prove that the compounds are the pure substances. Why pure substances? Because compounds will always contain one kind of molecule. Suppose if we take the distilled water, they will contain only H2O molecule. And what is the criteria for deciding? Suppose if we take 1 glass of water, it will contain only H2O molecule. This glass will be filled with the only H2O molecule, right? It means there is no other kind of molecule present. Okay, and suppose if I say this is made up of iron, this rod is made up of iron, so it may be containing only Fe atoms. Fe atoms are there. Okay, so this rod is only made up of iron atoms. So it means we can say the elements contain only one kind of atoms and molecules compound contain only one kind of molecule. So what is the criteria for deciding? If it contains only one kind of atoms or molecule, then we say this is pure substance. Since in compound they contain only one kind of molecule, so we say it is a pure substance, right? Second thing, why it is pure? Because we have not mixed anything. But when I say tap water will become impure. Why it will become impure? The tap water will become impure. Why it will become impure? Tell me. Because tap water is a salty water, some salts will be available in that, right? So if some salts are mixed in the tap water, it means it contains more than one kind of molecule. Suppose calcium, magnesium salts are there in the tap water, so H2O molecule is also there and NaCl is also there, or CaCl2 or MgCl2 is also there. It means it has become now mixture. Okay, but compound contain only one kind of molecule, and the compounds are always homogeneous. But mixture can be homogeneous as well as heterogeneous. Compound will always be homogeneous in nature. Okay, compound will always be homogeneous in nature, because when you see water always remains same. If it is a pure water, no problem, man. Okay, understood? So we can say compound will always have a compounds are always homogeneous in nature. They will be having only one kind of molecule. If there is one kind of molecule, then we say it is a pure substance. And the compound, there is a 10 minutes. Yeah. No, but it is because of not 10-minute gap. It is because of network connection it was disconnected, that's why. Okay, so I hope this is clear. So let's go back. So we were discussing, and whenever you see the compound shows the properties, that shows entirely different properties from the constituent particle. But when you see the mixture shows the properties of the constituent particle. But compound shows entirely different property from its constituent particle. Okay, so compound will always shows a different property from its constituent particle. The compound can be separated only by the chemical means, but the mixtures can be separated either by physical means. You can use any physical means like evaporations, filtration, fractional distillation, so many kind of. Okay, so let's go back to the slide which we have left. So we were discussing the difference between homogeneous mixture and heterogeneous mixture. Akhil, I hope your doubt is clear. Okay, so homogeneous mixture and heterogeneous mixture. Now when we talk about homogeneous, we have already understood a homogeneous mixture will have a uniform composition, and the particle of the mixture are not seen by the naked eyes, and the particles cannot separated by filtration. The mixture is always stable, right? Because in this case the particles do not settle down, because particle is very small in size, so they take the they occupy the whatever spaces are there in the liquid state. If you remember, we have done one activity in the beginning, when you dissolve sugar in water, so what is going to happen? Stop it here, the 7 minute, 8 minute, 10 minute. You pay attention in the study, whatever we are studying, right? Thank you. Okay, Akhil, good. So the mixture, we were discussing about the particle cannot be separated by filtration, because we have understood the pores of filter paper is bigger than the size of the particle, so they can easily pass through. Then we were discussing the mixture is stable. The mixture is stable. Why mixture is stable? Because the particle of homogeneous mixture will not settle down at all, and the path of the beam of light is not visible in the mixture. Now if you are taking the mixture of sugar in water, or mixture of salt in water, mixture of copper sulfate in water, they will not going to show the Tyndall effect. I will show you one picture through which you can see the Tyndall effect. Now you can see what is Tyndall effect, right? So Tyndall effect means when a beam of light is passed through a colloidal solution, the colloidal particles scatter the beam of light. The path of light becomes visible in the solution, and this effect is called Tyndall effect. Right? The Tyndall effect can be seen when the light enters the room through a very small hole due to scattering of light by the dust and smoke particle. Right? In the morning you can see, or sometimes you can see from the canopy of forest also, it can be seen if it is a dense forest. Right? There also the Tyndall effect can be seen. Right? So Tyndall effect can be seen in a dense forest due to the scattering of light by the water droplet in the mist. Right? And then Tyndall effect can be seen when the light enters a room through a small hole due to the scattering of light by the dust and smoke particle. Tyndall effect can be seen if the light be large enough to scatter the beam of light. But when we see in the colloidal solution or suspension, particles are larger, so they can scatter the beam of light. But in true solution, the problem is what? Suppose if we are making homogeneous solution, they are transparent. It means the particles are very small in size. They cannot be seen with the naked eyes. They cannot be separated through the filtration, and their size is less than 1 nanometer. It means their size is not large enough to scatter the beam of light. Now when you try the same thing with the colloidal solution, you can see the path of light is visible in this case. Okay, and here also when you try this, path of the light is visible. But when you try the same thing with the true solution, the path of light is not visible at all. Okay, the path of light is not visible at all. Okay, understood? So this is known as Tyndall effect. Okay, so let's go back to those properties. Okay, now the next is heterogeneous mixture. Heterogeneous mixture is a mixture which has a non-uniform composition because it contains impurities. Yes. Okay, so heterogeneous mixture is a mixture which has a non-uniform composition, and this can produce electricity also. Yes, salted water, tap water, because of the salts present in the water. Okay, and the particles are visible by the naked eyes. Why naked eyes? Because the particles are large enough, right? It means more than one nanometer. Their size is more than 1 nanometer. Okay, and the more than 100 nanometer, right? And the particles can be separated by the filtration. Now why they can be separated by the filtration? Because the particles are larger, right? The particles are, yes, Rudra, the particles are what? They are the large enough, to be separated, because their size is more than the pores of the filter paper, so they will remain up as a residue in the filter paper, right? And what is going to happen? So they can be easily separated with the help of filtration. Now the mixture is unstable. Why mixture is unstable? If the size is more than 100 nanometer, and if you have taken heterogeneous mixture, suppose sand and water, salt and sand, water, mixture of sulfur and iron filling, the mixture of oil and water, what is going to happen? This mixture is unstable. Why unstable? Because the particles are going to settle down at the bottom if you keep it undisturbed for some times. So let's see what is going to happen. Okay, so now you can see, if I take this beaker, right, and I have taken this salty water, salt and sand is there, it is there, right? Now when we keep it undisturbed for some time, you will observe that you can see the upper layer will become very clear. At the bottom, you will see the particles are settling down. You can see the particles are settling down at the bottom. Right? It means initially they were, roaming here and there, the particles were suspended, right? And if you keep it undisturbed, so you can see the sand particle will settle down. Sand particle will settle down and upper liquid layer can be seen. This is liquid layer, right? It means these kind of solutions are unstable solution. Clear? So initially it means whenever we see this kind of solution, they are unstable. Clear? Okay, and when the beam of light is visible in this mixture, yes, we can see. Why? Because the particles are large enough to scatter the beam of light, right? And in this case, the particle can be easily separated with the help of filter paper, we know that. And the mixture is unstable, we know that. Why? Because if you keep it undisturbed, the particle will settle down at the bottom, right? So let's see once again. I will show you. It means if you want to show the Tyndall effect, we can easily. It means these are what? If it is a sandy water, you will see the sand water in the sand will settle down, and then if you try to show the Tyndall effect, and you can easily show. Now on the basis of particle size, we can differentiate solution, or we can classify solution into three main types. One is what? A true solution is homogeneous mixture of two or more, right? A true solution is a homogeneous mixture of two or more substances, and solution has a solvent and solute as its component. Solvent means it is always in a large quantity, and the solute is always in a less quantity. Suppose if you have taken salt and dissolve in the water, so what is going to happen? Once again, continue. Yeah. Okay, so we have understood whenever we talk about true solution, it is a homogeneous mixture. We have understood the properties of homogeneous mixture. In this case, you can see the true solution is cannot, the particle of the true solution cannot be seen by the naked eyes. Why? Because when you talk about the particle size is less than 1 nanometer. We have already discussed in the previous slide, right? And true solution always have a solvent and solute in its component. Started buffering once again. My video is paused now. I hope this is connected once again, please. Okay, so we were discussing this. So we were discussing about the solution has a solvent and solute as its component, right? A solution has a solvent means the water, for example, right? And solvent is always in a large quantity, and the solvent is a chemical substance in which solute can be dissolved. Okay, so you can see solvent is always in a large quantity, and solvent is a chemical substance in which solute particle can be dissolved. And the solute is a substance in which solute is a substance which can be dissolved in the solvent, right? So true solution always has a solvent and solute as its component. For example, if it is a salt and water, the salt is what? Solute, and water is what? Solvent. Okay, and the component in the larger amount is the solvent, and the component in the lesser amount is the solute, right? For example, iodine in water, right? So tincture iodine, soda water, means carbon dioxide is there in the gas in water. Then whenever we talk about the properties of the true solution, we know that it is always homogeneous, they are transparent in nature, and the particles, right, the particles are cannot be seen by the naked eyes, and the solute particle cannot be separated by the filtration. We have already understood why, because their size is less than 1 nanometer, and the solute particle do not settle down, and it means the solution will always stable. If you take a true solution, the solution will always be stable. Why stable? Because particles are very small, so they will not settle down, they will occupy the spaces which is present in the liquid state. And particles do not scatter a beam of light. We know that particle size is very small, and they are okay. Now the next is colloidal solution. The colloidal solution is a heterogeneous mixture of two or more substances. For example, mixture of starch in water, or mixture of egg aluminum in water, or milk, or air containing dust and smoke. And the soap solution, you can add up more, like sometimes we are wearing some stones. The stones are also colloidal, and we are using gels, hair and jellies, bread. These all are colloidal in nature, right? Colloidal solution is always heterogeneous mixture. The particle cannot be seen by the naked eyes, right? And the solute particle cannot be separated by the filtration. But in case of suspension, this is possible because the particle size is more than 100 nanometer. The solute particle do not settle down. It means once again the colloidal solution are also stable, and the particles scatter a beam of light passing through the light. We have already seen, I have shown you twice the Tyndall effect. It means colloidal solution are going to show the Tyndall effect, but others are not. So whenever we talk about the suspensions is heterogeneous mixture of two or more substances. For example, solution of sand in water, solution of chalk powder in water, they all comes under this category, right? So whenever we talk about the properties of suspension is a heterogeneous mixture. Particle cannot be can be seen by naked eyes because the particle size is more than 100 nanometer, and that's why they can be easily seen by naked eyes. For example, if you are making a solution of sand in water, sand can be easily seen by naked eyes, and the solute particle can be separated by filtration. We know that sand particle is larger than the pores of the filter paper, so they can be easily separated with the help of filtration. And the solute particle will settle down after some time if you keep it this solution for some time undisturbed, right? For example, if you have added mud and the water, and if you keep it undisturbed for some time, you will see the mud particle will settle down, and the upper liquid will become translucent in nature, and the bottom will become opaque. Why opaque? Because all the particle will settle down at the bottom, right? So it means the suspension are always unstable solution, right? Because when you keep it, when you shake it, the particle will suspend. But if you keep it undisturbed for some times, you will see the particles will settle down. It means the suspensions are always unstable. One more thing I would like to add, you must have seen the suspension, like when you are small, your mother used to give if suppose some medicine, she used to shake that, right? Like the medicines are also coming in the form of suspensions, right? There we need to shake it before use. Why? Because we want the drug particle should present everywhere. We should not want to take only the liquid part. Okay, the particles scattered a beam of light passing through it, then the path of light is visible because the particles are large enough to scatter the beam of light, because the particle size is more than 100 nanometer. Right, now you can see how the solute particle can be separated with the help of filtration, right? The solute particles settle down. We know that if they are suspended in the solution, you can see they are suspended here, and if you keep it undisturbed for some time, these particles will settle down, right? These particles will settle down after some time. Okay, and they show the path of light also. It means they can show the Tyndall effect, right? And they can be easily separated with the help of filtration process. Okay, why? Because the particles are large enough from the pores of the filter paper, so they can be easily separated with the help of the solute particle which is present in the suspension, can be easily separated with the help of filtration. These three are very unique property of suspension. Solute particle can be separated by the filtration. Solute particle will scattered and the path of light is visible. Then solute particle will settle down, the solution is unstable, right? So I hope this is clear with everyone, right? Mm-hmm. with this, with the property of suspension, I'm going to end my class here. Okay, from the next we'll revise. Okay, I'm not going to end my stream because it is lagging, so I will complete this stream and then I will disconnect this.